Welcome to the Crazy Hat Chemist, so another video in kinetics. Bam! So, a kinetics calculation number 4. Yeah! So, determine the rate constant and the half-life of a first-order reaction which is 34% complete in 65 seconds. So, first of all, you do know that this is a first-order rate law, so you know which set of equations that you're going to use here. And these are the sets of equations. That's the integrated first-order rate law and the half-life associated with the first-order kinetics. Okay? So, is 34% complete in 65 seconds. So, how much do you start off with originally? You always start off with originally, and in terms of a percentage, 100%. Okay, so you're going to start with that and then think about 34% complete. Okay, so what that means is that you have 34% of it done already, and you start off with 100%. So you need to figure out how much remains after 34% is complete. So here's the math on this. If a reaction is 34% complete, then 100 minus the 34 is equal to 66% remains. Okay, hopefully that makes sense for you. So now what we're going to do is we're going to use the integrated first order rate law. Okay, and from that information we're going to solve for the rate constant. Okay, and then after that, then we're going to use the half-life equation and solve for the half-life. That's kind of the process of which we're going to use here. We have 65 seconds, that's our t of time, and we have the initial amount that's assumed to be the 100%. We have how much remains, that's 66, and therefore we can solve for that rate constant using the yellow integrated first order rate law. So there's the integrated first order rate law. We're going to plug in the appropriate values into that, and that is the 66% remains at time t, that's 65 seconds, and the 100% is the initial amount. What I am solving for is the k, which is the rate constant. So this time that natural log and the rules of natural log with a division problem and separating that out with subtraction, we don't actually have to do that here, which is super nice. So it's 66 divided by 100, take the natural log of that, and then there's a number on that left-hand side. And that's what that is right there. So that's negative 0.416 is equal to negative k times 65 seconds. We're going to divide both sides by negative 65, and then we have per second for the rate constant, of which is, of course, a positive value. It's always a positive value. So the rate constant here in this case is going to be 6.39 times 10 to the negative 3 per second. All right, hopefully that half of the problem makes sense for you. Now we have solved for the rate constant. Now we're going to solve for the half-life. So we're going to use the half-life equation, and that's right here. T of 1/2 is equal to natural log of 2 divided by k. We just solved for the k. We're going to plug in the k, which is the rate constant, into that problem right there, into that equation. And that's what I've done there. T of 1/2 is equal to natural log of 6 divided by 6.39 times 10 to the negative 3 per second. Natural log of 2 is 0.693, and then we're going to do that division problem, and then this is the value for the t of 1/2, that's the half-life, is 108 seconds. So now you have the rate constant, you have the t of 1/2, and now you're set to go. Bam! I like that. Okay? That is another Crazy Hat video, and I got a crazy hat for you. I got this from one of my students, so thank you very much. Give me a thumbs up if you like that video. Subscribe to my YouTube channel. See me on the web, on my website, for all my videos. And have a great day, and I'll see you next time. Bye for now.